Fine. Today our topic is OSPF, Open Status Path First. OSPF stands for, and it's IGP protocol. It is Interior Gateway Routing Protocol, means IGP protocol. And apart from that, it's Layer 3 protocol. It is a Layer 3 protocol, and it is a link state routing protocol. We'll discuss what is link state. And earlier we discussed about hybrid model, that is EAGRP. And because EAGRP having a link state feature and as well as distance vector routing protocol. So the EAGRP having a combination of link state as well as distance vector. Why it is, we'll discuss. So ESPF, OSPF will work based on the SPF algorithm. So SPF stands for shortest path first algorithm it uses, and to verify, and OSPF neighborship will form, and apart from that, with the basis of SPF algorithm, it will be select the best path. Apart from that, we call it as a Dijkstra algorithm also, and it is a classless routing protocol. What does that mean? Classless routing protocol. What does it mean? Classless routing protocol, Monica? What is a classless and classful? Difference between classless and classful? Anyone can answer. Yamuna, or anyone.
I think like in classless we use like 8 MPS and 18 and 24. I think so. Like this. Three.
Okay. What
And
does
in
it mean?
classful,
Slash 24, slash 8, slash
yeah,
16.
slash.
Okay. What does it mean?
It's called classless. Anyway, I mean it used in classless.
Hmm.
And in classful, I think we use like what we say 2, 4, like that. Some numbers.
Read here what it is there.
Classful routing protocols do not carry the subnet mask information along with update, which means the all device in the network must be use same subnet marks. It's
Okay. And this one?
classless rout- routing protocols carry the subnet mask information along with update updates. That's why they support subnet marks VLSM and FLSM.
Okay. What does
And
that mean? Okay, fine. Got it. So what does that mean? Class full means it will be not carry the subnet mask information. It means whenever the class full, so we have a slash class C CIDR values class C. So we have a slash 24, and class B CIDR values 16, and class C class A, sorry, class A CIDR values 8. So these are the full subnet mask. It will be carry the only class full subnet mask, not carry the subnet mask information of whichever the V si- divided with the basis of VLS variable length subnet mask, like slash 23 and slash 25 slash 27 something, whichever the value slash 17, which all are comes under. VLSM, variable length subnet mask. This is a fixed length subnet mask. That is what. So here we have a OSPF also. OSPF also classless routing protocol. It's good thing actually. It will be carry the with subnet mask. It will be carry the with subnet mask. So that is what. Fine. Go through
Okay,
this. It's an important thing. Classless and classful thing. Okay. So and OSPF uses the protocol number that is 89. 89. And what about the EAGRP protocol number is EAGRP protocol number is OSPF is a 89. What about the EAGRP? EAGRP protocol number is 88 and this one is 89. So with the basis of protocol number, we'll identify the service again. We'll identify the service, which service is there. Oh, if you want to, whenever we are using ACLs or in firewalls, firewalls will allow or will deny the services, whichever the requirement basis will allow or will deny the services. Will allow or if you want to deny, yes, we can deny with the basis of the protocol number and port numbers. And RIP protocol having the port number is 520. So with the basis of we can identify the service. It is UDP port number. UDP port number. So in case of OSPF protocol, all the routers will having full topology information. So whenever we are using the OSPF, yeah, OSPF is the only protocol we have it IGP protocol. In IGP, it will maintain the entire topology information. Entire topology information it have. So how it will be having, we'll discuss some overview. So here, actually OSPF is the area concept. So we have a two routers. They are directly connected, and first we they will form the neighborship. Once they form the neighborship, this router will share entire routing information. That is, we call it as a LSA, link state acknowledgement. Link state advertisement. This is the advertisement. Entire links. If this router having another connectivities, like this is the one branch, this one another router, another router, another router. This router, how many routers having the connectivity? This router having so multiple prefixes like 100 VLANs or 100 of prefixes. This router having 100 of prefixes, LAN interfaces, VLANs, hundreds of VLANs. This router having hundreds of VLANs. This router having hundreds of VLANs. This router having hundreds of prefix information. Once we configure the OSPF in between routers, it's an entire topology. It's kind of one topology. OSPF topology. This router will share to neighbor. Thus, I do have this many link state acknowledgement, link state advertisement. This is what link state protocol. It will be share the entire link information. How many these neighbors have, that many it will be shared. And first of all, you should have to know what is a OSPF. OSPF work based on the LSA. LSA, link state advertisement. Link state advertisement
4731.
means how many links they are directly connected, and that directly connected. Apart from that, how many routes we advertise it through in OSPF? We advertise it through OSPF network command 100 prefix. This router R3 will share to neighbor And R2, what it will be do? He will share with neighbor. So this router, which router? This is the router. This router having entire topology information. One more thing, if any prefix is went down in this VLAN, we, as I told, hundreds of prefixes are there. In that prefixes, only one VLAN 10 is goes down. Some reasons VLAN 10 is goes down. In that VLAN, we have 192.168.10.0. This is the prefix we have actually. This is the prefix we have. So whichever the prefix is goes down, that prefix only share with neighbor. So this router will share with him. So it will be not share entire routing table. If any changes occur in topology, whichever the changes occur, that thing only will share. That thing only it will be share. It will be not share entire routing table. So here we have a timers also. In OSPF, 10 second is a hello timer and that timer is a 40 second. It will be vary based on the network type. But by default, the timer is here 10 and 40. And here you can assume it's 10 into 4 times means 40. So 40, it's a dead timer, 4 times of hello timer. So whenever the router will send every 10 seconds, you are alive or not. You are the my neighbor two, neighbor router two. You are the alive or not. You are the alive or not. It will be sent. If this router is not giving the reply till 40 seconds, this router will assume like my neighbor is not alive, not alive. So then this router will remove the connectivity, remove the neighborship. So that is what. So again, it will be sent a periodic update. It means whenever the changes occur, that time only it will be sent. Whenever any changes occur, that time only it will be sent. So that is the timer. And apart from that, this is a neighborship and it will be work based on the LSA, link state advertisement. So the how many neighbors are connected and that neighbors how many prefixes are advertised, those many prefixes will advertise to neighbor. So it means this router having entire topology information, entire topology information, this router having entire topology information, who and all directly connected or indirectly connected. So that is the benefit of OSPF. Now move forward. So so as we discussed, the router having full topology information. So for that, how they will share the routing information, whichever the routes information they have, how they will share together, they will use two multicast IP addresses. Those are 224.0.0.5 and one more is 224.0.0.6. The OSPF only the protocol we have, it will be used
Actually,
to
family.
multicast IP addresses. It will be used to multicast IP addresses. In that, one is 224.0.0.5. Yes. Anyone have any question? Fine. So in that too, guys, if you don't have any questions, please mute yourself. So it will be used to multicast IP addresses. In that 224.0.0.5 and one more is 224.0.0.0.6. 224.0.0.6. So can anyone tell me? So we have a RIP also uses the one multicast IP address and EIGRP also will use one of the multicast IP address. What is RIP multicast IP address? RIP multicast IP address and EIGRP multicast IP address. So RIP version 2 uses for multicast IP address. That is here you can check. Already we discussed.
2 to 4.0 here.
That is 0.0.9.
0 0.
It's 9 just, and this one is 10. It means 224 dot 0 dot
0
0 dot
0
9
9
and 224 dot
0 dot
10. So don't forget these things. So what about the here we having two multicast IP addresses? In that it will be used to send hello updates and packets with the help of these values and used by the DR routers. And in the two values, this 224.0.0.5, it will be used only DR and BDR routers, and this will be used only for DR other routers. Why we'll discuss later on, but just remember those values. And here OSPF will use metric as a cost, and for that metric calculation, here we have a metric calculation 10 to the power of 8 by bandwidth, interface bandwidth. So this is the formula we have 10 to the power of 8 by bandwidth. How we'll get, I'll discuss. And it is a IGP protocol, interior gateway protocol, and OSPF protocol support unequal cost. So sorry, it will be used unequal cost, not it will be only used equal cost load balancing. Unequal cost it will not use basically. That is what, and it will be support unlimited hope counts. It will be support unlimited hope counts. RIP having only up to 15 hope counts, and EAGRP having 100 is by default hope count, and 255 are the maximum hope count. But here OSPF will having unlimited hope counts, and it will be support. EHRP will support unequal and equal cost load balancing, but here the OSPF will support only equal cost load balancing. What does it mean? If we are having two paths 100 Mbps and 100 Mbps, so then only it will be shared information 100 MB, 100 MB. If we instead of 100 here we have 50 MB, then it will be not support. Only it will be support equal cost load balancing. So if you have any questions, still
We can't hear you.
Alim, your voice is
Sorry.
not audible.
Okay. Sorry, I'm on mute that time. Sorry. So OSPF here we'll discuss. So here message type hello messages. It uses the established neighborship between routers and it used it as a keep alive messages between the routers and it will send after every 10 seconds. This is hello timer seconds between the routers and it will be used the multicast IP address 224.0.0.5 as a destination. What does that mean? Here, first of all, the neighborship we configured it in this router. In this router, we configure as a router OSPF. Some will use OSPF, some 100 as a process ID. Then we advertise some network. So apart from that, this router starts sending hello messages every 10 seconds. So we have not configured here. Just we configured in this router only. So this router start to send hello messages. It's kind of down state. So here we have a different states also. Meanwhile, we'll discuss state as well as messages. So here we have a down state, init state, two-way state, start and exchange, loading and full. We have a 7 types of states. So each and every state with messages will discuss. What is the use, how they will send, and we'll discuss everything. So first, I'll use this image here. So first of all, the router 1 and router 2, you can assume this is a router A or router 1, A or B or 1 or 2. So first, this router we configured neighbor as a OSPF. We configured OSPF everything in this, and we advertised it through network command, these prefixes, which are the directly connected interfaces. We advertised those things. So this router start to send hello messages. That is what hello messages. So every 10 seconds, this router will send to this router hello message. That is, we call it as a down state because we have not configured this router until. So this router will send with nil null updates. That is, we call it as a null update. That is, it is a init state also. So once we haven't configured that, you can assume down state. Once we configure this router and we haven't configured it in neighbor router, that is init state. But this router is sending the hello messages every 10 seconds. So that is in it. Apart from that, we configured both end. So here we configured and here also we configured and we advertise. So they start to neighborship establish. That is a two-way state. That is a two-way state. Once we configured it both end, that is a two-way state. So they will exchange with router ID and whichever the prefixes they have. They start to send router ID. And once the whichever the, how the election will establish, I will discuss here. We the in two-way state election will be done. That is DR and BDR election will done. How it will be election will be done. We'll discuss. Just here first we will discuss something exchange start state. It in that start state, what they will exchange entire database description. As I told, this router having hundreds of prefixes, so hundreds of LAN prefixes. They will start to exchange those are prefixes. So that is what link state advertisement headers. So once they will state, so this router will acknowledge also. So both first this router will send. So router two. So meanwhile, first what happened? Down state means no neighborship. Init state means one router we configured as a router OSPF and another router we haven't configured. that is init state, and two-way state means we configured both ends. They start to exchange hello messages and neighborship will be formed. Some neighborship parameters are there. I will explain, and the DR BDR election also is there. That will be happening two-way state. We'll discuss that thing. Apart from that, they after then they will exchange the DBD, database description packets. This is a message type. So database description, it the router one exchange, whichever the highest router ID having, that router will be exchanged first. Then whichever the least router ID means, whichever the DR other routers, they will give to him only. First, he will ask. So whichever the DR router means designated router, that is a master router. The master router will only the leader here. The leader only asks to the neighbors, DR other routers, whichever the prefixes you have, give me. I'll update to you other neighbors. So what is the process? We'll discuss. So apart from that, they will exchange entire package after then exchange state. After then, once exchange done, then if any packets are missing, so he will request, and if any packets are missing, he will request. If any packets are missing, can you give me that also? That is the request message. He will update through link state update. If anything else, he so 192.168.10.0, the prefix is missing. So he will ask that earlier you have sent that prefix. Now still you having that prefix. Can you send that? He will give the update. That is what. Then he will give the acknowledgement. That is what. So here link state request, link state update, link state acknowledgement. Entire process will be happen in these states only. So after they will share together, then it will be moved to the full state. The neighborship will form successfully. So how the neighborship will form? Some criteria is there, some requirements are there. What those requirements we'll discuss now. So for neighborship, we have some must match requirements is there. Neighborship parameters between two routers. First of all, area. So router will work based OSPF will work based on the area concept. OSPF will work based on the OSPF concept. For example, this is my area 0 and this is my area 10 and this is my area 20. Whichever area you need, you can configure it. So that time in that routers, whichever you are configuring, area should how to match. Then only they will form the neighborship. Otherwise, if different area, if you are configuring, then area will not match, then neighborship also not form. Area ID must be matched between the two the routers. So if you want to configure area 22 0. So here we have a edge router. Here we have a edge router. Yes, you can configure in between. So here the area whichever you are configuring, area 0 or area 20, whichever you can take it. But the area should how to match. How you can configure. We have a edge router. This will be comes under area 0 and this interface comes under some whichever area you are taking that in between interfaces. So whichever you are configuring in between interfaces, that should have to match. That is mean. And router ID must be not match. If you are using here router ID 1.1.1.1, you cannot use 1.1.1.1 here also. If area is both are same, then also neighborship will be not formed. You should have to use some different router ID. So authentication type match. It will be if you are using password is a ABC here and ABC here should how to match. And authentication data must be matched. So data and type should have to match. If you are using here, we have a MD5 and SHA algorithm. SHA authentication both it will be so SHA and MD5 it will be support. OSPF will support two types of authentications. So whichever the if you are using here MD5 and should how to use MD5 both end. Otherwise, it will be not form. You are using here MD5, another side you are using the SHA means it won't form the neighborship. The authentication should have type also must match. And authentication should have to match. Whichever the password you are giving, that should have to match. And subnet mask, whichever the in between you are configuring, though this segment subnet should have to match. So in between the subnet, if you are taking /24, apart from that, whichever the IP address you are configuring, that should have to, if you are configuring one means you have to use same in this subnet only. The IP address have to different. So that much only. The subnet also match. And network type here we have a point-to-point broadcast network, multi-point broadcast. Some network types also is there that should have to match. And MTU size by default maximum transmission unit size is 1500. Those that size also match. And the sub flag must match. Here we have some special area. Those are the special areas also match. Whichever you are configuring, that should be matched. So we have a NSSA, stub area, totally stub area. Those special area concept we have, that is advanced topic, but whichever you are using, that area should have to match. These are the parameter 8 neighborship parameters. If match, then only neighborship will be formed. Otherwise, neighborship will be not formed. So apart from that, here we have. So these are the message types, and these are the router ID. How the router will elect the router ID. Now we'll discuss the router ID. It will be unique identity. Means what is router ID? So router ID, the concept is here. So every router, this is a R1 router. If you are configuring as a R1 router, if you are giving something name 1.1.1, so OSPF topology, this is the name, it will be considered as a, this is the router. It will be kind of name, whichever you are giving the unique IP address, this is the format only. Again, IPv4 format and 32 bits format only. We will configure 32-bit format, that is the router ID. The router ID is unique, it's kind of name for that router. So OS in OSPF topology, it will be considered as a that router name. So router ID will always represent in decimal number and IP address format. That is what in IPv4 format, there are few ways of election router ID. So if you are not configuring router ID, so it will be elect by default. If you are not configuring the router ID in OSPF, in OSPF protocol, it will be elect by default. So how it will be elect? First of all, it will be check if you are configuring the manually. So we have a manual configuration also for router ID. Just we'll move to router and we'll give the router ID. I'll show you how we'll configure the router ID in lab. If you are not configured the manually, then it will be moved to the highest loopback interface. Loopback interface is a virtual interface. It's kind of virtual interface. So if you are not configuring virtual interface also, so in that also highest virtual interface it will be elect. If you are not configuring virtual interface also, if that will be elected based on the highest physical IP address. Here physical IP address F0 by 0 and F0 by 1 and F0 by 2. We have a different ports. Here we definitely will assign some IP address in that whichever the highest IP address. If you configure 10 here, if you configure 20 here, if you configure 30 here, so whichever the highest, that will be elected as a IP route, highest router ID. So that is elected as a router ID, highest physical interface. So for example, if you configure 10.10.10 10.10. If you configure here 20.20.20, if you configure here 30.30.30, so whichever the highest, 30 is the highest value, so it will be considered as a, that is the router ID. So first it will be checked manually. Second, it will be checked the loopback IP address. Third, it will be checked the physical interface. If both are not in present, if they are present, then it will be elect. So that is what router ID. So again, step back. We'll discuss the. So here, down state, init state, two-way state, DRB. So in two-way state, only DR, BDR election will be done. So first, down state means we have not configured the neighborship. So first of all, we'll discuss here. To in down state means one side we configure or one side also not configured at OSPF till. So init state means one side we configure and another side we haven't configured. So they it start to hello messages. So two-way state means we configure both end. So they are starting to they form the neighborship entire route. So here we have some parameters of neighbor parameters. So entire thing match. Then they will establish a neighborship at R1 and R2. That is two-way state. The DR and BDR election also done. And what is DR and what is BDR? DR stands for designated router and BDR stands for backup designated router. So first of all, in OSPF topology, one is a DR router and another is a BDR router. This one you can assume this is a DR router and another one is a BDR router. Apart from that, if we have multiple routers also, so those are the DR other routers. Those are the DR other routers. Then how it will be elected? Highest highest priority. So whichever having the router priority by default is it will be one priority by default one. So whichever if you want to change, yes, you can change 0 to 255. If zero is there, that will be not elected as a DR router. Always that is a DR other router only. So by default priority is one. If you configure 255, 255 is the maximum value. 255 is the maximum value. If you configure as a 255, this router always DR router. If you configure this value as a 254, this will be always DDR router. So likewise, it will be elected. If priority is high, by default priority is one, and if priority is high, then it will check the highest router ID. As we discussed how the router ID will be configured. So if we configure something highest router ID on this 100.100.100 something, so here we have a 99.99.99. So in that it will be elected based on the highest router ID. So highest router ID is the DR router, and apart from that, whichever the least through compared to highest DR router, that will be elected as a BDR router. Apart from that, all are the DR other routers. In two-way state, it will be election will be done. After then, in start state, in this state, router exchange DVD messages together. So towards each other, they will exchange database description and they will negotiate. In this state, router negotiate MTU size also. In this state, master and slave election will be happen. So if we are using here point to point connectivity or serial cable, that time DR-BDR election will be not happen. So if you are using point to point or serial link, if you are using fast Ethernet, okay, that time DR-BDR is there. If you are using serial link, that is earlier we are usually will use, that is 1544 kbps speed only. Nowadays we are not using. So even though on that routers, the master and slave election will be done. So whichever the having the again same conditions here, it will be having the priority. It will check it will check the highest router ID. Same it will be checked. So now move forward. Here, master, this concept will be in serial link. You can check, and in this serial link, we never get BDR BDR concept. This router whose router ID will be highest one, so that router will be elected as a master router. That is what. As I told, in serial link concept, the master slave election will be happen. Nowadays, we are not using the serial link because the link having the less bandwidth, less speed. So based on that, nowadays we are using the Ethernet links only. Ethernet links only. Ethernet, fast Ethernet, gigabit Ethernet, 10 gigabit Ethernet. Those links only we are using nowadays. So now move forward. Exchange, exchange state. In this state, router will exchange the header of LSA, link state advertisement towards each other, but not going to send their database. So they will exchange. This router will ask, can you view your whichever the link state updates are there? So this router, they are together. They will this router will send. He will store. This router will send. He will store likewise. And once they will exchange done, then in this state, loading state, in this state, routers will exchange database of those empty LSAs. So once they will exchange means what happened, router 1 and router 2 here, they are exchanging till router ID. Router IDs they will exchange. Once the election entire thing properly done, so one router will be elected as a DR router and another router as a BDR router. So in this BDR router and DR router, they will use 224.0.0.6 value and 224.0.0.6. So this is the multicast IP. Through they will receive the entire information. Once they receive, they will responsibility to send to other routers, DR other router through 5 multicast IP. They will exchange at full state. Once in this state, router will be full state, and now they will having complete information of the neighbor devices and database. So here we have some tables before the database. Router devices maintain database in case of OSPF protocol. The OSPF database contains all the LSAs. So here we have some database table. So we have some tables here. One is neighbor table, one is database table, one is routing table. Routing table. In that neighbor table means they will have neighbor information. In database table means how many prefixes, how many routers are connected, entire topology information this router have. In routing table means whichever the it's a global routing table, whichever the shortest path that will be stored in routing table. So I'll show you how we will verify this. I'll show you in lab. So some LSS we have here. So it will be work based on the link state advertisement. As I mentioned, the OSPF only the protocol, link state routing protocol we have here. It will be work based on the LSA types. So here we have a multiple types of LSS 11 in that we'll use up to here in that also 6 means multicast IP address. It will be not support. A Cisco will not support this LSA 6. So LSA 5, 1, 2, 3, 4, 5, and 6. So what is LSA 1? It's a router LSA actually, and 2 is a network LSA. LSA 3 is a summary LSA, and ASB are LSA area autonomous system boundary router LSA and external. These are the same. These both are the external LSAs. This one is the not source hubby area. So first we'll discuss two LSAs today. So all routers generate their own router LSAs within the same area. So as I mentioned here, OSPF will work based on the area concept. This is area 0 and this one is area for 10. So LSA 1 will originate router LSA in that particular area only. It will be not cross. LSA 1 also, LSA 2 also. In what is the difference between LSA 2, the DR and B, whichever the DR. So only DR router will having power to generate LSA 2. So in that DR router only will generate the LSA 2. So now LSA 3 means we have, if this LSA 10 router area 10 prefixes this router 1, so in between we have a one router, in between we have a one router, that is we call it as a area border router. Area border router only generate the LSA 3s, and we have a LSA 4 and 5. So whichever if you are using here some EIGRP protocol. We redistributed prefixes through EIGRP to OSPF. So these are the LSA files. So whichever are redistributed prefixes, those are the LSA files. So if we want to minimize, if we want to filter some prefixes, that is with the basis of stub area, we can filter. So if you want to filter some prefixes, LSA 4 or 5, this we can filter it. If so, this router having EIGRP prefixes, area 10 prefixes, means here we are getting the 1 lakh prefixes, here we are getting the 1 lakh prefixes. So 1 lakh means 2 lakh prefixes these routers are getting, means which is a CPU utilization, more CPU utilization. So that time if we want to filter those prefixes, we'll give the one by default route towards that areas, that EIGRP protocols. So that is the sub area concept. That is an advanced topic. So here we use LSA in real time. We'll use mostly LSA 1, 2, 3, 4, 5, and 6, 7. One. These all are the OSPF concept. If you have any queries, ask me. Now we'll move to the lab. If you don't have any questions, then we'll move to the lab.